Hello and welcome to my channel, and in today's tutorial we'll be solving 9709 paper 12 May-June 2021. So while I'm solving, I will also give you important tricks and helpful hints so that you can ace your upcoming AS level exam. Before we start with the first question, make sure that you have your formula sheet with you, and if you haven't subscribed to my channel, make sure that you hit the subscribe button because it really motivates me and I can create more videos that are helpful for you. Okay, so let us begin. Alright, so we are solving 9709 paper 12 May-June 2021. Let us see what's the first question. Question number 1 is express 16x square minus 24x plus 10 in the form 4x plus a bracket square plus b. So here we can see that this is completing the square and I'm having 4x in the front. Yeah, so we're going to approach by a different method, not the traditional completing square method. Of course, we're going to complete the square, but with a different and much more easier method for this type of question. So we know that a minus b bracket square is going to be a square minus 2ab plus b square. Yeah, so if it was plus in here, the middle sign would be plus, so plus 2ab. I'm choosing negative because I see over here the middle sign is negative. Now, since over here I'm having 4x as the first term is 4x, so I'm going to write this as 4x bracket square. So I'm trying to apply this rule over here. So my first term is 4x over here. So I'm going to take 4x bracket square, which gives me 16x square. Then applying the rule again, it's going to be 2 times 4x times b, which I don't know, and then b square. Right? So let us think what should be the value of b in that case. Okay, so it's going to be the middle term. So we are having minus 2 times 4, which is minus 8. So minus 8 times what gives me a negative 24. So minus 8 times 3 gives me negative 24. So I got the middle term, which is now if I multiply it out, it's going to be negative 24x. 4 times 2, 8. 8 times 3, negative 24. Then the last term has to be 3 square, because if I compare it with this formula over here, my b was 3. So it's going to be 3 square. Again, this works out to be 16x square minus 24x plus 3 square, which is 9. And we need to subtract what we added. Additional thing that we added over here was 3 square. So we need to subtract that. And then we are having over here plus 10. So we just write the plus 10 as it is. So what has happened now? We have transformed this into a square. So this bit is a full square. So this is going to be then 4x minus 3 bracket square. Right? And then we have minus 9 plus 10. That gives me 4x minus 3 bracket square plus 1. That is the completed square. So that should be your answer for part A. So part B, it is given that the equation 16x square minus 24x plus 10 equal to k has exactly one root. Find the value of this root. Now remember, one root, that means b square minus 4ac is equal to 0. So let us set it up and find out what is b square minus 4ac. Move this to the other side. So we have 16x square minus 24x plus 10 minus k equal to 0. So a is 16, b equal to minus 24, and c equal to 10 minus k. So b square minus 4ac is equal to 0. So minus 24 bracket square minus 4 times 16 times c, which is 10 minus k, equal to 0. So minus 24 bracket square works out to be equal to 576 minus 16 times 4 is 64 times 10 minus k equal to 0. Let us expand. That gives me 640 plus 64k equal to 0. So 576 minus 640 gives me minus 64 plus 64k equal to 0. So 64k is equal to 64 and hence k equal to 1. Well, this is the value of k. Now we need to find out what would be the value of the root. Yeah, so we have 16x square minus 24x plus 10 minus 1 equal to 0, or 16x square minus 24x plus 9 equal to 0. Now we just find the roots. It's going to be a perfect square. 4x minus 3 bracket square equal to 0. That means 4x minus 3 is equal to 0, or x is equal to 3 over 4. Yeah. Question number 2. The graph of y equal to fx is transformed into graph of y equal to 2 times fx minus 1. So we need to describe two single transformations that have combined to give us this result, the resulting transformation. So we can see over here there's a number 2 multiplied, and also the x is having negative 1 over here. So here this is a vertical stretch by factor of 2, and this one is a horizontal translation. So now when we have a vertical and a horizontal transformation, it doesn't matter in which order you apply that. So clearly the order does not matter here, because one is vertical and the other one is horizontal. So we can write it in any order. So let's write translation by this vector. The x is changing, so 1 comma 0. Remember, if here you're having negative 1, the translation would be 1. X is a naughty 1. If it's minus 1, you write here 1. Stretch with scale factor equal to 2 parallel to y-axis. Alright, so that's part A. Part B, the curve y equal to sine 2x minus fx is reflected in the y-axis, and then it is stretched by a scale factor of 1/3 in the x direction. We need to write down the equation of the transformed curve. So here let me give a little bit of theory about reflection in y-axis. So if it's reflection in y-axis, it's going to be y equal to f of minus x, yeah, and if it is a stretch by scale factor 1/3 in x direction, it's going to be y equal to f of ax, where the scale factor is going to be 1 over a, right? This is how it is. So it means that we need to replace your x value with y equal to sine, if you write it as minus 2x minus 5 minus x, okay, and also we need to replace the scale factor, which is also in x, that is, if the scale factor is 1 over a, the value of a is 3. So it's going to be then, this is going to be then minus 2 times 3x minus 5 times minus 3x, yeah. So here this minus sign is because of the reflection in y-axis, the 3 is because of stretch in the x direction, yeah, minus because of reflection, and 3 because of the stretch. So you got to remember that y of sine minus 6x is same as minus 6 sine x, okay. So this is going to be then 15x. So this is going to be y equal to minus sine 6x plus 15x, yeah. That is going to be your final answer. The gradients of BE, CE, DE rounded to 4 decimal places are 1.9748, 1.9975 and 1.9997 respectively. State giving reasons for your answer. What the values of the 4 gradients suggest about the gradient of the curve at point E. So these are the gradients for BE, CE, DE. So we can see that the gradients are clearly approaching to 2, right? So first thing that you would write is the gradients, or the gradient is equal to 2, yeah, because we can see that they are approaching to 2. And what is the reason that they are approaching to 2? So before we write down the final answer, I would like to explain this a little bit. So if I look at the points, I'm just going to copy it down there. So if I look at these points, which are B, C, D and E, let us look at their x coordinates. The x coordinates are trying to approach to 3, yeah. So we could say that the gradient, if you try to draw a curve, so we have B, let's say C, D and then E. So if I try to draw a chord from like this and trying to find the gradient of the chord, eventually as your x value approaches to 3, the gradient tends to 2. That's what you're going to write, yeah. So the gradient at E, we would say that is a limit of gradients of the chords. In this case it is BE, CD, DE. It's a limit of the chords as x tends to 3. That would be your reason. So for this type of question, you need to look at how is the x changing, yeah. So it's getting closer to 3 and the gradient is getting then closer to 2. So how is that possible? Because you're coming closer and closer. So it is the limit of gradient of chords as x tends to 3, yeah. So that would be your final answer. Question number 4. The coefficient of x in the expansion 4x plus 10 over x to the power of 3 is p, and the coefficient of 1 over x in the expansion 2x plus k over x squared to the power of 5 is q. Given that p is equal to 6q, find the possible values of k. So let us see what we have here. We need to find the coefficient of x, okay. We need the coefficient of x and that coefficient is p. And then we also need the coefficient of 1 over x from this expansion. So a little bit of theory over here. So the general term could be given as NCR a to the power of n minus r b to the power of r. In our case, we need to find the coefficient of x, yeah. So we need to set up a small kind of equation, because you can do it mentally or you can set up an equation. So we need the coefficient of x. So here we are having n is 3 from here, yeah. Let's keep the r empty at the moment. So we have 4x to the power of n minus r. We don't know what is r. And we need the value of b. b is 10 over x to the power of r. So we need to find what should be the value of r such that we get the coefficient of x. So you could do it mentally or you can also set up equation. So what equation can you set up? I'm just going to change the font color so that you can see. Here we know that the value of n is going to be 3. So I can write over here n is 3, yeah. So the equation would be x to the power of 3 minus r times x to the power of minus 1 times r, yeah. This is equal to x to the power of 1. So if I ignore the x's, I'm left with 3 minus r is equal to 1. Why is this x to the power of 1? Because we want to find the coefficient of x, yeah. So let's solve this one. So this is going to give me 3 minus 2r equal to 1, or we can say that 2 is equal to 2r and r is equal to 1. So we now know that the value of r should be 1. So I can just put this on the side for now. Let's put it on this side. Let's make it small, right? So we have the value of r is 1. So that's going to be 3c1, 4x to the power of 3 minus 1, which is 2, and 10x to the power of 1. You can see that x squared divided by x is going to give me just x, yeah? So this coefficient is now then going to be equal to p as per the question, yeah? So let's calculate what is 3c1. So 3c1 is going to be equal to 3, and 4 square is going to be 16, and that's going to be 10x. We can ignore the x's because we are interested only in the coefficient, yeah? So the coefficient is going to be then 480. That 480 should be equated to p, right? So that's the coefficient of x. Now we need to find the coefficient of 1 over x in this second expansion. So I'm going to follow the same rule, yeah? So I'm going to set up an equation for it, and then I'm going to try and see what I'm going to get, right? So I have x to the power of n minus r. So 5cr, x to the power of n minus r, and we have x to the negative 2 to the power of r. So if I set up the equation, it's going to be 5 minus r minus 2r. Why is it 2r? Because I'm having 2 times r, so minus 2r, and we want the coefficient of 1 over x. So it's going to be equal to -1, yeah? I'm just writing the final expression for the equation. You could watch some more videos of mine based on the binomial expansion to understand thoroughly how to rewrite these equations. I've explained in those videos the complete method of writing the equations if you're still struggling on that. So we now know that it is going to be 5c2, 2x to the power of 5 minus 2, which is 3, kx negative 2 to the power of 2, yeah? So this is going to be 10 times 8x cube times k square over x to the 4th. So that's going to be 80 k square over times 1 over x. So if I ignore that 1 over x, the coefficient is 80 k square, that's equal to q. And it is given to us that p is equal to 6q. P is equal to 6q. So that means 480, which we calculated over here. P is equal to 480 should be equal to 6 times 80k square, which is then 480 equal to 480 k square. So k square is equal to 1, and then the value of k should be plus or minus 1. Square root should give you plus or minus 1, and it is asking for possible values of k, so we can write both. K equal to plus or minus 1. That's about this. Question number 5. The function f is defined by fx equal to 2x squared plus 3 for all x greater than or equal to 0. Find and simplify the expression for f of x. So that means you have to take f and substitute it back in place of x, yeah? So f of x is going to be then 2, and here the x is going to be replaced by your fx again, yeah? So that's going to be 2x squared plus 3, right? Now we need to simplify this, so we need to expand it. It's a good idea to write it twice. Let's write it 2 times and then expand the brackets. So that's going to be 4x to the 4th plus 6x squared plus 6x square plus 9. As you would expand normal brackets, yeah, FOIL, use the FOIL to expand like that. Plus 3, so that gives me then, let's combine these two middle terms. So 2 times 4x to the 4th plus 12x square plus 9, and then now let's multiply out by 2. So multiply 2 with all the three terms here. So that gives me 8x to the 4th, 24x square, and plus 9 times 2 is 18 plus 3, which simplifies to 8x to the 4th plus 24x square plus 21. Yeah, so that's the first part. Then we have part B. We need to solve f of x is equal to 34x square plus 19. All right. So 8x to the 4th plus 24x square plus 21 is now equal to 34x square plus 19. So let's bring everything to one side and make it equal to 0. So 8x to the 4th plus 24x square minus 34x to x square plus 21 minus 19 equal to 0. Let's combine the like terms. So 24 minus 34 is going to be equal to negative 10. So 8x to the 4th negative 10x square, and 21 minus 19 is going to be then equal to positive 2 equal to 0. We can surely divide everything by 2. So let's do that. So it's going to be 4x to the 4th minus 5x square plus 1 equal to 0. Now this is complex quadratics, chapter 1, because you have x to the 4th and x square. Yeah, if you like, you may substitute, let a equal to x square. Then this is going to be 4a square minus 5a plus 1 equal to 0. And now we factorize 4a square minus 5a plus 1. Yeah, so what are the factors over here? If there aren't any factors, then you will have to use quadratic formula. Yeah, so the factors are 4a minus 1 and a minus 1 equal to 0. So that gives me a is equal to positive 1/4 or a equal to positive 1. So x square is equal to positive 1/4 or x square is equal to 1. That gives me x is half and x equal to 1. Why did I choose only positive values? Because it is mentioned in the question that x is greater than or equal to 0. So we choose only positive values. So these are the two values of x, and that's the answer for part B. Question number 6. Points A and B have coordinates 8, 3 and P, Q respectively. The equation of perpendicular bisector is given as y equal to minus 2x plus 4. We need to work out what are the values of P and Q. Alright, so we have points A and B given to us, and also the equation of perpendicular bisector. Remember, the perpendicular bisector passes through the midpoint of the line AB. Yeah, so it passes through the midpoint of the line AB. So over here what I see is I have two unknowns, P and Q. I also have the gradient of the perpendicular bisector is minus 2. That means I know what is the gradient of AB. Yeah, so I'm going to use that fact first. If there are two unknowns, I need two simultaneous equations which I need to somehow find out. Yeah, so the first equation could be formed by using the knowledge that if the gradient is negative 2 for the perpendicular bisector, the gradient of AB would be 1 over 2. Yeah, so the gradient of AB would be then 3 minus Q over 8 minus P, that is equal to 1 over 2. And let's cross multiply. So 2 times 3 minus Q is equal to 8 minus P. So 6 minus 2Q is equal to 8 minus P, which simplifies to minus 2 equal to 2Q minus P. I just moved the 2q to that side, and I got the 6 minus 8 on this side. So that's the first equation I have. And I'm going to try and find another equation. So I know that the perpendicular bisector, it passes through the midpoint. So let us try to find the midpoint of AB, and then we can see that the midpoint, the line has to pass through the midpoint. Okay, so we'll try to do something with that. So the midpoint of AB would be x1 plus x2, so 8 plus p divided by 2, 3 plus q divided by 2, and the perpendicular bisector passes through the midpoint. So I can clearly substitute this point in place of x and y of the perpendicular bisector. So I'm just going to do that. Y equal to minus 2x plus 4. So we have y, which is 3 plus q divided by 2, equal to minus 2 times 8 plus p divided by 2 plus 4. The 2 and 2 gets cancelled. So we have 3 plus q divided by 2 equal to minus 8 plus p plus 4. Let us expand and simplify. It gives us 3 plus q divided by 2 is equal to minus 8 minus p plus 4, and that simplifies to 2 times minus 4 minus p. So q, 3 plus q equal to minus 8 minus 2p, or we can say that 2p plus q is equal to minus 11. That's the second equation. So I have two equations here. This is the first one. Let me just copy it down there. You can now solve this equation either by either by substitution or by elimination. So I'm going to make use of substitution. So q would be equal to negative 11 minus 2p. I'm going to substitute that in here, the second one, minus 11 minus 2p minus p. So that is minus 2 equal to minus 22 plus 2 times 2 is 4, p minus p, and that gives me negative 5p. So p equal to negative 4, and hence we know that q would be equal to, if you substitute in place of p negative 4, it's going to be 11 minus 11 minus 2 times negative 4, that is minus 11 plus 8, that is going to be negative 3. So q is going to be equal to negative 3. That's about this question. Question 7. The point A has coordinates 1, 5, and the line L has gradient negative 2, 3, and it passes through A. A circle has center 5, 11 and radius square root 52. Show that the line L is tangent to the circle at point A. If the line is tangent to the circle, so it means that it should intersect the circle at only one point, right? So what is the equation of circle? It's going to be x minus 5 bracket square plus y minus 11 bracket square equal to square root 52 square. So that's basically 52 then. And the equation of the line is going to be y minus y1 equal to m into bracket x minus x1. That's the equation of circle. So if I have to solve these two simultaneously and then try to show that they intersect at only one point, that means b square minus 4ac should be equal to 0. Yeah. Question number 7. The point A has coordinates 1, 5 and the line L has a gradient of negative 2/3 and it passes through point A. A circle has a center 5, 11 and radius of square root 52. We need to show that the line L is tangent to the circle. Now, if a line is tangent to a circle, there are a couple of things happening over here. First thing is that if a line is tangent to the circle, the radius will be perpendicular to the tangent. That's the first thing. Second thing is that if we solve these two simultaneously, b square minus 4ac should be equal to 0. So you can use either method to solve this. So we have this center which is 5, 11, and we have the point A as 1, 5. So if the line is tangent to the circle, then the gradient of the radius should be negative reciprocal of gradient of the line L. Yeah, there are two things over here. We already know what's the gradient of line L, which is negative 2/3. If we can prove that the gradient of the radius is going to be then 3/2, we can say that the radius is perpendicular to the line, and hence the line has to be tangent. Or you may want to solve the two equations simultaneously, equation of circle and equation of the tangent. Okay, so what's the equation of the circle? The equation of the circle is going to be x minus 5 bracket square plus y minus 11 bracket square equal to square root of 52 square. Right? So that is x minus 5 bracket square plus y minus 11 bracket square equal to 52. That's the equation of the circle. Now let us find the gradient of the radius. The gradient of the radius is going to be, we are then going to make use of the center 5, 11 and the point 1, 5. We try to find the radius, the gradient of the radius, I mean. So x2 minus x1, then that is going to be 5 minus 11 divided by 1 minus 5. That gives you negative 6 divided by negative 4, which is nothing but 3/2. And the line L has gradient negative 2/3. Alright, we can see now that the gradients are negative reciprocal. So we know that the radius is then perpendicular to the line L. But we also have to show that this point 1, 5 is lying on the circle, because over here in the question doesn't state that the point A is on the circle. So what we're going to do is substitute the point A 1, 5 in the equation of circle, which is x minus 5 bracket square plus y minus 11 bracket square equal to square root of 52, or is equal to 52. Yeah, so when you substitute 1 minus 5 bracket square plus 5 minus 11 bracket square, that gives you, if you calculate that, it will give you 52. So you say that since the gradients are negative reciprocal, and point A lies on the circle, it is tangent to circle. Right? Let's look at part B. Find the equation of other circle of radius r for which the line L is also a tangent. So we know that we have a circle, line L is the tangent. Let me just draw the line L here just to explain the concept. And we have another circle for which line L is also the tangent. So we need to now find out what is the equation of this circle. So we know the point A, which is 1, 5. Yeah, point A is 1, 5. We also know the equation of the circle, the center of the circle, which is 5, 11. And we know that the radius is the same. Yeah, the radius is the same. So we kind of think that what would be the center of this another new circle. So you think about, we have this point A, which is 1, 5, which is in the middle. Then we have one circle center, which is 5, 11. Center 1, let's call it as center 1, 5, 11. And now we need to find center 2. The radius is the same, right? So you got to think if the radius is the same, so how far is this from the center? So this is going to be -4. So you go -4. This is -4. So from here, if you go -4, we're going to reach at 1 minus 4. That's -3. And if you look at the y coordinates, it is -6. 11 minus 6 gives you 5. So you do -6 here. So 5 minus 6 gives you -1. So we know that the center is going to be then -3 and -1, and then we can write the equation of the circle would be x plus 3 bracket square plus y plus 1 bracket square. That is going to be again 52, because the radius is square root 52. Remember, square root of 52 square is equal to 52, right? So that's about question number 8. The first, second and third terms of an arithmetic progression are a, 3/2a and b respectively. So we have an arithmetic progression with terms a, 3/2a and b, where a and b are positive constant. The second and third terms of geometric progression are a, 18 and b plus 3. Find the values of a and b. Okay, so there are two cases over here. First one is arithmetic. The second one is geometric. You know that arithmetic progression has a common difference. That means second minus the first is same as third minus the second. Yeah. So if we solve this, this is going to be 1.5 minus 1, which is half a, is equal to b minus 3/2a, or we can move the a to the other side, which simplifies to half plus 1.5. That is going to be 4/2, which is 2. 2a is equal to b. That's the first equation we get. And then we have a geometric progression. A geometric progression will give you common ratio. That means second divided by the first is same as the third divided by second. So if you cross multiply, you're going to have 18 square is equal to a times b plus 3. So 18 square is going to be 324 equal to a times b plus 3. Okay, so we need to solve these two equations simultaneously. Clearly, we can substitute b from here in there. So 324 is equal to a times 2a plus 3. So 324 is equal to 2a square plus 3a. So we have a quadratic here, 2a square plus 3a minus 324 equal to 0. Try to solve this quadratic. Let's see if we have the factors. You can use the calculator for that purpose to check the factors. So we have a is equal to 12, or a equal to negative 27/2. So the factors are a minus 12 and 2a plus 27. Remember, you have to write the factors. If you don't write the factors, you do not get any marks, right? So it's given to us that a and b are positive constants in the question. That means we can reject this bit because it's not positive. So a is 12, and that means b should be double of it. B is going to be 24. So that's the part A. A is 12 and b is 24. Now, let's go on to the next part, part B. Find the sum of first 20 terms of the arithmetic progression. So we found a and b. So let us write down what are the terms over here. So the arithmetic progression is this. So let's copy that and substitute what is a and b. So we're going to have a is 12. So the first term is going to be 12. And then 3/2 times 12. So it's going to be 1.5 times 12. It's going to be 18. And that's 24. So we know that the common difference A is 12. The common difference is going to be 18 minus 12, which is going to be 6. So sum of first 20 terms, n is 20. So 20 divided by 2, 2a plus n minus 1 times d, which is 6 in this case. So let's calculate that. So 20 divided by 2 is 10. 10 times 24 plus 19 times 6. This works out to be 1380. So that's the answer for part B. That's about it for question number 8. Before moving on to question number 9, if you haven't subscribed to my channel, make sure that you hit the subscribe button, like, share, and comment if you would like to see any particular paper, right? Question number 9. The diagram shows part of the curve with equation y square equal to x minus 2 and the lines x equal to 5 and y equal to 1. The shaded region enclosed by the curve and the lines is rotated through 360 degrees about the x-axis. We need to find the volume obtained. So we have the curve y square equal to x minus 2 and we have the line y equal to 1, and we need to find the volume enclosed by the shaded region. So first step would be to try and find what is this point of intersection. Yeah, so we have y square equal to x minus 2 and we have y is equal to 1. So if you solve them simultaneously, 1 will be equal to x minus 2. That gives me x equal to 3. Now we need to integrate between the limits 3 to 5. Yeah, fx square minus gx square, that's the formula for the volume. So that's going to be from 3 to 5, fx square is y square, that is x minus 2, gx square is y equal to 1. So this is fx square and this is gx square. So gx square would be 1 square dx. So that is going to give me then 3 to 5 x minus 3 dx, which is x square over 2 minus 3x, and then we substitute the limits 3 and 5. So first the upper limit, that gives me 5 square over 2 minus 3 times 5, which is 15, and then the lower limit 3 square over 2 minus 3 times 3, which is 9. So let's calculate that. That gives me 6.28 or 2 pi. Yeah, so that's the volume. Question 10, part A. Prove the identity 1 plus sin x over 1 minus sin x minus 1 minus sin x divided by 1 plus sin x is equivalent to 4 tan x over cos x. Okay, so we're going to start with the left hand side, and we need to think how we can obtain the right hand side. So the first step I'm going to thinking about is, because it's like fractions, so what can you do with the fractions? You make the denominators same. That would be the thought process, to make the denominators same. So in the denominator I'm having 1 minus sin x times 1 plus sin x, and in the numerator we're having 1 plus sin x. You cross multiply. So when you cross multiply over here these two, it becomes bracket square minus 1 minus sin x bracket square. Alright, for numerator you need to expand. So 1 minus sin x and 1 plus sin x. So you can use the formula if you like, or you can simply expand it on the side. So 1 plus sin x bracket square is going to be 1 plus sin x times 1 plus sin x, or you can use the formula a plus b bracket square. So that's going to give me 1 plus sin x, yeah, and then you use the FOIL, plus sin x plus sin square x. So that gives me 1 plus 2 sin x plus sin square x. So it's going to be the same thing for the negative, but the middle sign would be negative. So we are having 1 plus 2 sin x plus sin square x, then minus, For the negative, the expansion would be literally the same with the negative in between for 2 sine x and then sine square x. Denominator, surely I'm going to make use of a formula which is a plus b times a minus b is going to be equal to a square minus b square. Using that, here a is 1 and b is sine x, so it's going to be a square minus b square. Let's expand the bracket in the numerator. So we have 1 plus 2 sine x plus sine square x minus 1 plus 2 sine x minus sine square x divided by 1 minus sine square, that is nothing but cos square x. So in the numerator, plus 1 minus 1 gets cancelled, plus sine square minus sine square gets cancelled. So we are left with 4 sine x, and in the denominator we have cos square x, which I am going to write it as cos x multiplied by cos x. The reason being, if you look at the right hand side, you have tan x. Yeah, tan x is nothing but sin x over cos x. So this is going to be 4 tan x. I used up one of the cos x to form the tan x, and then we are left with another cos x in the denominator. So that's your right hand side. So that's about this question number 10. Part B. Hence solve the equation. If you look at the left hand side, all of this is nothing but now equal to 4 tan x over cos x. So we're going to replace that with 4 tan x over cos x. A good idea would be, let's say if you're not able to prove the first part, you should still go ahead and try to solve the next part. Yeah. So cross multiply. That gives you 4 tan x equal to 8 tan x times cos x. Get everything to one side. So 4 tan x minus 8 tan x cos x equal to 0. Now in order to solve, you need to factorize this, because otherwise you cannot solve this kind of equation. So we can take 4 tan x as a common factor. So you're left with 1 minus 2 cos x in the bracket. So when two terms multiply to 0, either one of them should be 0. So 4 tan x is equal to 0, or 1 minus 2 cos x is equal to 0. So that gives me 1 equal to 2 cos x, or cos x is equal to half. And on the other side here, we have tan x equal to 0. So x is going to be then tan inverse of 0. You should be in radian mode, and here x is going to be cos inverse of half. The calculator has to be in radian mode. So what do we get? So if you put it in a radian mode, tan inverse of 0 is going to be equal to 0. The second angle you can have is you add the period. But if I add the period of tan is going to be pi. So if I add pi, I'm going to go beyond the given range. So I do not add the period. Whereas for cos inverse of half, we are going to get pi by 3. That's the first angle. So x equal to pi by 3. And the second angle is always going to be 2 pi minus what you obtained, the first angle. So it's going to be 2 pi minus pi by 3, which is equal to 5 over 3 pi. Yeah, which in decimal is 5.2. Again, it is greater than the given range, which is just pi by 2. So we can reject that one as well. So the only correct answers would be x equal to 0 and x equal to pi by 3. That's about this question. Question number 11. The gradient of the curve is given by dy by dx equal to 6 times 3x minus 5 to the power of 3 minus kx square, where k is a constant. The curve has a stationary point at 2, negative 3.5. Find the value of k. So we have a stationary point at this given point. Stationary point means dy by dx is equal to 0. So I'm going to equate the dy by dx equal to 0, and also I'm going to substitute the value x and x equal to 2. So 6 times 3 times 2 is again 6 minus 5 power 3. 2 square is going to be equal to 0. So let's calculate that. So it's going to be 6 times 1 cube, which is 1. So 6 minus 4k equal to 0. So 6 equal to 4k, or k equal to 1.5. 3 over 2, which is 1.5. Now we need to find the equation of the curve. Once we have the value of k, we can rewrite the dy by dx as 6 times 3x minus 5 to the power of 3 minus 1.5 x square. Yeah, and now if we integrate this, we are going to get the equation of the curve. So y is equal to, we need to integrate this one. So you are having here 3x minus 5 to the power of 3. Remember to apply the chain rule while you integrate. So this is going to be 3x minus 5 to the power of 4 divided by 4 times the differentiation of the bracket. The differentiation of the bracket is going to be 3. So times 1/3 minus 1.5 x cube divided by 3 plus the constant. So let us simplify this a bit. So I'm going to just simplify 6 divided by 4 times 3. So 6 divided by 12, basically that is going to be half. 3x minus 5 to the power of 4, and 1.5 divided by 3 gives me half again, x cube plus the constant. Now we need to find out what is the constant of integration. So for that we are going to use the same point, because this point is lying on the curve. So 2 and negative 3.5. So substitute 2 and negative 3.5. So in place of x you substitute 2, and then let's calculate what do we get the value of c. The value of c is equal to 0. So c is equal to 0. So your equation would be for the curve half 3x minus 5 to the power of 4 minus half x cube, because the value of constant is 0. That's the answer for part B. Part C, find the second derivative. Okay, so we have the first derivative given to us, and we found the value of k as well. So let me just copy this one. And now we need to differentiate it again to calculate the second derivative. So the second derivative is then going to be, bring the power down, so it's going to be 18 3x minus 5 times 3, that is the differentiation of the bracket over here, and then bring the power down again. 1.5 times 2 is 3x, I forgot the power here, so it should be power 2. Yeah, so that's the differentiation. And now we need to determine the nature of the stationary point at 2, negative 3.5 in part D. So we substitute x equal to 2 in the second derivative. So what do we get? So we get 18 bracket 3 times 2 minus 5 to the power of 2 times 3. Okay, I forgot to simplify that. So 18 times 3, I guess it's 54. 3x minus 5 to the power of 2 minus 3x. So let's write in here 54 minus 3 times 2. Calculate that if it's positive or negative. So 54 times 1 minus 6, that gives you 48, which is greater than 0. So we say that it's a minimum at 2, negative 3.5. That will be more appropriate. All right then. So that's question number 12. The diagram shows a cross section of 7 cylindrical pipes, each of radius 20 centimeters, which are held together by a thin rope which is wrapped tightly around the pipes. The center of the 6 outer pipes are A, B, C, D, E, and F. P and Q are situated where the straight sections of the rope meet the pipe with center A. Show that the angle PAQ is 1/3 pi radians. So this angle, we need to prove that is 1/3 pi radian. So if you look at this figure, you will notice that this can be divided into 6 equal sections. Yeah, if I draw over here the entire circle, the circle can be divided into 6 equal sectors, we would say. The circle is divided into 6 equal sectors. So we can say that let this angle be x, yeah, or PAQ. So we have 6 times angle PAQ. The total of angles around a point is always equal to 2 pi, and then angle PAQ is equal to 2 pi divided by 6, which is 1/3 pi. It's important to note over here that you need to mention that there are 6 equal sectors. If you don't mention that and you just write down this, it doesn't mean anything. Yeah, so you have to write that the circle is divided into 6 equal sectors. Now we need to find the length of the rope. So the length of the rope is the one which is tightly wrapped around like that. Yeah, so let's look at the length of the rope. We have some straight sections and we also have some sectors over here. So this is the arc length for this sector. Yeah, and then we have straight sections as well. So let's find the arc length, and how many such we have, we need to count that. So arc length is equal to r theta, and we know that the radius is equal to 20 centimeters. It has been given to us over here. Radius is 20, so it's going to be 20 times pi by 3, which is going to be 20 pi by 3. I'll just keep it as it is, and let's identify how many arc lengths do we have. 1, 2, 3, 4, 5, 6. So we have 6 arc lengths. Yeah, so that's going to be, total would be 6 times 20 pi by 3, which simplifies to 40 pi. And we also have some straight sections. So if you notice over here, that's a straight section. Yeah, so what would be the length of this straight section? So it is going to be the same thing over here. We know that the radius is 20, so it's going to be 20 plus 20. The length of the straight section is going to be then 40. Yeah, the radius 20 plus 20, so the straight section is going to be 40, and we have 1, 2, 3, 4, 5, 6 straight sections. So the length of the rope would be 40 pi plus 6 times 40. So that works out to be 365.6. So we can write it as 366 approximately. Yeah, so that's the length of the rope in centimeters. Now part C, find the area of hexagon A, B, C, D, E, F and give your answer in terms of square root 3. Okay, so we need to calculate the area of this entire hexagon which is inside over here, and we need to give it in terms of square root 3. If I can find area of one triangle, then I multiply it by 6. I will get the area of hexagon. So this is area of one triangle we need to calculate. So what would be the area of one such triangle? Yeah, so we know that this angle is pi by 3. This angle is also pi by 3. Of course, this angle also will be pi by 3. So it's an equilateral triangle. And we also know that the lengths are 40. Yeah. So what I'm going to do is I'm going to use area formula. So area of a triangle is going to be half AB, so 40 times 40, sine of pi by 3. Okay, so since the answer is expected in terms of root 3, I'm just going to do the calculations manually. So this is times root 3 over 2. So I'm going to then divide 1600 with 4. So 1600 divided by 4 is going to give me 400 root 3. That's the area of one triangle. So the total area is going to be, we have 6 such triangles. So that's going to be 2400 root 3. That's the area of the hexagon. Find the area of the complete region enclosed by the rope. So we found the area of the inside hexagon. Yeah. Now we need to find the area of this complete region over here. Okay. So how are we going to do that? So if you look over here, would use some different color to just highlight. This entire shape could be divided into rectangle, sectors. Yeah. So just shade the sector. So sectors, we are going to have 6 such sectors, and also we are going to have 6 rectangles, and we are going to have the center hexagon. Since we already found the area of hexagon, which is in the middle, this one, we found this area. I'm going to just find the area of the sector and the area of the rectangle and add them up to calculate the total area. So we know that the rectangle is 40 times 20. Yeah. So this is 40 and the side length is 20. So area of rectangle is going to be 40 times 20, and we have 6 such rectangles. So we're going to multiply it by 6. So 40 times 20 times 6 gives me 4800. Area sector is going to be half r square theta, which is 20 squared times theta is pi by 3, and we have 6 such sectors, so multiplied by 6, so the 6 gets cancelled off, so it's going to be 400 pi. And area hexagon, which we already calculated, is 2400 root 3. So the total would be then, adding all of that up, gives me, in 3 significant figures, would be 400 pi plus 4800 plus 2400 root 3, which is 10,213.559. We can round it off to 10,200, correct to 3 significant figures, centimeters square. Yeah, that would be the answer for part D. And that's about this exam. So we have completed the paper. If you have any questions, please comment on this tutorial and subscribe for more.